Okay, today's chapter is elasticity. Elasticity. Okay, what is elasticity? Elasticity is the property of a substance to regain its shape and size after the withdrawal of the deforming force or after the withdrawal of the external force. That property is called elasticity. Just keep in mind, very simple. We are having rubber band. Rubber band is elastic in nature. When we stretch it, we withdraw the force, it returns back. Or at least it has tendency to regain its shape and size, original shape and size. That property or that tendency is called elasticity. Spring. Let us take the case of a spring. Spring, when we stretch, once we withdraw the force, what happens? Spring returns back to regain its shape and original size. Then such a property is called elasticity. And the reverse of elasticity is called plasticity. Plasticity. The body will not regain its original shape and size. We are stretching a body, or we are applying a force on a body, and body does not return back to its original shape and size. Such a body is called plastic. And the property is called plasticity. Plasticity. Just the reverse of elasticity. I think you understood this. What is elasticity? One of you please share with me. What is elasticity? The property of a body to regain or to return back, you can say any one of the words, to regain its original shape and size after the withdrawal of the deforming force. We are applying on the body, the force must be deforming force. Which will change the shape and size. That means we must be applying the force on a non-rigid body. And when the body returns back to its original shape and size, then this property is called elasticity. And the body is called elastic body. The substance will be called elastic substance or elastic body. I gave example like rubber band, rubber cord. We can have many examples. We have spring. They all are elastic in nature. And when the body does not return back to original shape and size after the withdrawal of the deforming force, then the body is said to be plastic, and the property is called plasticity. Plasticity. Have you understood?
Yes, sir.
Boys, have you understood it? Thank you. Actually, why it shows plasticity and why elasticity is there? Okay, let us find a reason for it. Okay, the reason is, in every substance there are molecules, and molecules have intermolecular force, and the molecules also have intermolecular space or intermolecular separation. Okay, it is seen that when the molecules are very close to one another, the force between the molecules will be repulsive in nature, will not be attractive, rather repulsive force will be there. And when the molecules are at a longer distance or larger distance, then the force between them will be attractive in nature. And when the distance of the molecules is too large, the force of attraction will be negligible. The force of attraction will be negligible. So I can explain to you, by giving one example. Let us take a spring. I'll take one spring. I'll compress it like this. I'll compress. And once I release, what happens? They go back to the original shape and size. They will be repelling each other. Molecules of the are coming closer, and once we withdraw the force, we see that they are repelling each other and coming to the same position, original position. So this is the example where it proves that The molecules on coming closer will be repelling each other, will not be attracting. And now let us take the spring and stretch it. Make the molecules to go far apart, far apart. When the molecules are, once I withdraw the force, where will the spring come? The spring will be coming, closing like this. So this example proves or suggests that when the molecules are going far away, they will have a force of attraction between them. We'll have intermolecular force of attraction. But when they are very close or too close to one another, they will have the intermolecular force of repulsion. And when the molecules go far apart, very long distance they are going, it may break. So the force of attraction is negligible. When you stretch too much, too long distance, the body may not return back to its original shape and size. They will return back, but not exactly to its original shape and size. So that is the intermolecular force of attraction becomes very weak in that case. Force of attraction is there, but the force of attraction is not strong, it is weak. There are three situations: when the distance is very close, and when the distance is large, and the distance is very large. I think you understood the situation, no? What happens? For this situation, we draw a graph, okay, to show how the intermolecular forces are acting within the molecules of a solid. For that, we draw a graph to explain this. Here I am writing force. This side is force, and this side I write here intermolecular distance. Molecular separation. Here at 0, and this side at repulsive. This is repulsive force, and this side attractive. Or that means force of attraction, attractive. The graph will come typical curve, and it comes like this. It will be coming from here like this. This way it will come. It will. So the graph draw like this. That means this is, here you can write, this is the point, here you write. This one you will be writing here, near distance is close distance, near distance. Okay, and here you will be writing, this separation will be large distance, and here you will be writing very large distance. Very large distance, right here, weak force of attraction. Here, large distance, you will be writing strong force of attraction, strong force of attraction. And near distance, right, force of repulsion. Of course, strong force of repulsion. You write. So this is the graph you draw. The graph does not touch this, okay? It will come like this way, it will come. That means the force of repulsion is quite strong, and this is called equilibrium distance, R naught we write here, R naught. Here the force is 0. Attractive force and repulsive force, they cancel each other, and the molecules will be in equilibrium. They will neither attract nor repel. at a particular distance. That happens before we apply a force on it. Suppose I take a solid here and I'm not giving any force. All the molecules are in equilibrium. Means they are at such a distance between each other that they are experiencing neither the force of attraction nor the force of repulsion. That distance is termed as R0. R0 means force is zero. This force value is zero. Attractive force and repulsive force cancelling each other, and net force is zero here. Net force becomes zero. That distance is called R0. But if your distance is lesser than that, I mean, when you are pushing it, I mean, applying the force and compressing it, the molecules will, then they will experience the force of repulsion. And when you go far away from this distance, there will be strong force of attraction. And when you go too far away, then the force of attraction only will be there, but it will be very weak. Just have a look at it. It will be very weak force. Hope you understood this. Tell me any point you want to clarify, please. Let me know. Yes. Do you have any point to clarify? Okay, fast. Now tell no.
So clear.
Okay, thank you. Have you understood what is elasticity? Elasticity is the property of a substance or of a body to original shape and size on the withdrawal of the deforming force, on the withdrawal of the force which we are applying in the body to change its shape and size. Once we withdraw the force, the body will have tendency or will have the property to regain its original shape and size. Hope you understood it. Okay. Now some terms related to elasticity we will do. Okay. First one, write down here stress. Stress. What is the stress? Force per unit area of cross section of a body is called stress. So stress formula will have F by A. The force applied per unit area is called stress, and we write F by A. Force by area is called. Have you understood? That is it is a type of pressure. You can say that it is a type of pressure. But pressure times the force will be always normal to the surface, normal. Normal force per unit area is called pressure. So it is a kind of pressure only. The SI unit, you can write here SI unit. SI unit is Newton per meter square. We like that, Newton per meter square. Or we can write Pascal. PA. Pascal is a unit of pressure, same as Newton per meter square. So SI unit of stress is Newton per meter square or Pascal. Is it a scalar or vector? Can you tell me what type of quantity would be this? Stress is a scalar or vector? Anybody? Say fast. Yeah. Hello.
Yes, sir.
Huh? Stress is a scalar or vector?
Scalar.
Scalar, because
Vector.
pressure is a scalar. I told you. It may have direction, but it is still a scalar. Like pressure and current, I gave two examples, which are having unit and dimension both, yet they are scalar. The answer was current and pressure. This is a kind of pressure, so it is a scalar. Okay. Next one, you write down strain. Next term which we use in this chapter is called strain. What is the meaning of strain? Change in dimension. Hello. Please mute your audio. Who is it? strain is the change in dimension with respect to the original dimension is called strain. You can write a change in dimension, either dimension or shape, change in dimension with respect divided by original dimension. Original dimension is called strain. Suppose I give one example. Suppose length of a body was 1 meter. Once we stretch it, the length becomes 1.2 meter. How much is the change? Change dimension taking place is how much? 0.2 meter. 0.2
meter.
The 0.2 meter out of what was the original value? 1 meter. No, the 0.2 divided by 1. That is the value of strain. That will be the value of strain. This change in the dimensions per original dimension is called strain. What is the unit of strain? What is the unit? Can you guess what is the unit of strain? What will be the unit of strain? Tell me fast. What can be the unit of strain? Hello? No response. At least guess no. What is the harm in guessing?
Sir, meter.
So
Meter. Huh? Think for a while and then give an answer.
Sir, Newton meter.
Huh?
So strain. So what's the question?
What is the unit of strain?
Yes, sir.
What is the unit? The unit of strain is no unit. It doesn't have a unit. You can think no here, come on. Changing the dimension is maybe meter. This is also meter. The meter cancel. So how will it have unit?
Yes, sir.
So the unit is no unit.
So dimensionless.
No unit. Dimensionless, yes. Neither unit nor dimension. It has no unit. Done?
Yes, sir.
Okay. Now there was a scientist. His name was Hooke. 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 He gave a law. Okay. All the Hooke and almost it's named after him only. Actually, Hooking. You all have seen the Hooke, no Hooke. Okay. There was a scientist. His name was Hooke. He gave a law. It's called Hooke's law. Hooke's law of elasticity. Hooke's law of elasticity. Hooke's law of elasticity. Hooke's law of elasticity. He said, or Hooke's law states that the stress is directly proportional to strain. Stress is directly proportional to strain within the elastic limit of the body. Within the elastic limit. What is the meaning of elastic limit? There is a limit, up to which the body will show the property of elasticity. Beyond that limit, the body will become plastic, will never come back, will not return. It will remain. Suppose you are elongating something, keep on elongating. Too much elongation will cause the body to remain elongated, will cause the body not to return back, not to come back. But at a particular length, you see the body is returning back nicely returning back. So that means the body is within the limit of elasticity. But beyond that, the body will become plastic. The body will not return back. So within elastic limit, as long as the elasticity is working, elasticity is in force, then stress will be directly proportional to strain. He said that. Stress, you can analyze stress is directly proportional to strain. Stress is directly proportional to the strain. And what is the limit of this? Within the elastic limit. Okay. So we can divide that as stress by strain equal to, we write a constant, no, constant of proportionality. Here the constant of proportionality, we denote it by E, capital E, and this E is known as modulus of elasticity, modulus of elasticity, modulus of elasticity. That is, modulus of elasticity is the ratio of stress to the strain, as simple as that. And what information does it carry? Elasticity will carry what information, or modulus of elasticity carries what information? It tells you how elastic a substance is. How much elastic? It is very or less elastic. It carries that information. Suppose when the value of E is very high, that means the body is highly elastic. It means that the body will have more tendency, or the body is returning back more to its original dimension, more perfectly returning back. And when the value of E is less, the body is returning back, but not up to that accuracy, to that perfection. Body is less elastic. We can say the body is less. Though both the bodies are elastic, but one is more elastic, one is less elastic. It carries that information. Can you guess what will be the unit of elasticity or modulus of elasticity? In short, we are just measuring elasticity. Like, friction, we measure by coefficient of friction of a surface. How much friction a surface will give, that is measured by the value of mu, which we have used coefficient of friction. If the value of mu is more, we say the more friction is available. The value of mu is less, we say less friction is available. Similar way, this has got the same meaning. Can you guess what is the unit of elasticity? What can be the unit of elasticity? Tell me. What can be the unit? Please see the equation and tell me what can be the unit of elasticity.
Sir, Newton meter square. Sir, Newton per meter.
Newton per meter square. This one. Still doesn't have a unit. Stress unit and elasticity unit will be the same. These two will have same unit. Unit of stress and unit of elasticity will be the same. Okay, can we find dimension of elasticity? What can be the dimension? Dimension will be same as the dimension of pressure. Pressure is force upon area. That means use that dimension of force mLT minus 2 divided by L square, and your answer will come what? ml minus 1 T minus 2. So that can be the dimension. If person asks you what is the dimension of elasticity, you can work out. It will have same dimension as the stress, or it will have same dimension as the pressure, force by area. All right, understood? Say, boys.
Yes, sir.
Okay. Now, just think and answer and tell me, okay? Rubber or steel, which one is more elastic? Can you guess? Which one will be more elastic, rubber or steel? Say fast.
Rubber. Or steel.
Okay. Whatever answer you are giving, you have to give reason also. Okay. Somebody said rubber. I think opal. Why is rubber is more elastic?
So, so because it has
Because
more
tendency
potential to
to-
be stretched.
Okay. And more potential to be stretched. That is the meaning of elasticity. Elasticity meaning is more tendency to return back to its original shape and size. That is called elasticity, no? More elastic means more tendency or more property of returning back to the original shape and size. It is not the property of getting more, elongated or, having more value of strength. It's not that. Now tell me which is elastic. The answer is steel. Steel is more elastic than the rubber. Because you just think about a spring. The spring is made up of steel. Once you withdraw the force, it returns back more perfectly than the rubber. Rubber will
Yes, sir.
be returning back, but there will be slight elongation in it. You can just try and check out. You know, initial length is suppose 10 centimeters. After you stretch it and release, it returns back. Maybe the length, new length will be 10 point something centimeters. It won't be accurately 10. Or keep on stretching like this many times. You will find that the length has increased. But there is still many times, I mean, spring, which is made up of steel, you do like this, return back. Many times you do, there is hardly any change. There will be change, but the change is negligible. You will not be able to notice it. Have you understood? You have seen this one of the bull worker, you know, the spring is there, you know, to do exercise. Huh? Boys, have you seen it? You can use it for many days and it does not get elongated. So that is the, property of steel. Steel is more elastic. But to answer this, we say like this, let's see. For the same strength produced, we answer like this. For the same strength, that is, for the same elongation, you can say, or for the same change in dimension, stress is more steel than the rubber. When the stress is more, then the elasticity will be also more. I'll just give one example. Let us take a rubber cord and take a spring here, like this steel. This is rubber, this is steel. Same length, initial length and get keeping same. Okay, let us change this dimension. Rather, I'll elongate both of them by applying we want to elongate it by the same dimension, same length. Suppose 1 meter, 1 centimeter I'll expand, and here also 1 centimeter. In which case you have to give more force. In which case you have to give more force, rubber or steel?
Steel.
Steel will be required more force to produce the same amount of elongation as in rubber. So that means to have same strength, we find stress is more in steel than the rubber. When the stress is more, the elasticity will be more, and on that basis we say that the steel is more elastic than the rubber. You know, the force which we apply, that is called deforming force. But once you withdraw it, the same deforming force will change into restoring force. Restoring force, the force which will be bringing the body back to the original position. Restoring force. The deforming force and the restoring force will have equal values in elastic body and will be opposite in direction. Such a force is called restoring force. But within elastic limit, all these things happen within the elastic limit. There is a limit to it. You keep on stretching, so it may not, they may not be directly proportional in that case. This property will fail. Or you keep on stretching and the body may break. That also may happen. The body may become plastic or the body may break even. If you go beyond plasticity, the body will break. So the hook says that stress is direct proportional to the strain, but within the elastic limit. Understood? I think today we can do this much. Tomorrow, I think the theory part of this chapter will be over because this is a short chapter. Tomorrow I will be talking about the types of elasticity or types of modulus of elasticity. There are 3 types. E has got 3 types. One is called Young's modulus, denoted by Y. Other one is called Bulk's modulus, denoted by K. And the next one is called modulus of rigidity, and that is denoted by N. YKN. About that I'll talk tomorrow. I'll discuss tomorrow about that. Okay, most probably tomorrow only theory part of this chapter will be finished. and then we will be doing only the problems. So today I taught this much. I only slightly introduced the chapter. Tomorrow we'll carry on with some formulae and all. Hope you understood so far. Any questions in your mind? Yes.